I'm Mark Denny, product manager in the access point team on the 3K access points as well as the modules and .11ac from a product management perspective. I'm also here with Brian Hart.
Yeah, g'day. I'm Brian Hart. I'm working in the Strategic Initiatives Group, long-time wireless LAN veteran. Make, fly chips from like a decade ago. Done a lot of standardization on 11N, 11AC, 11AD, wide gig, and so forth.
And some client examples. So we've actually, this guy is actually one of the prototype early AC modules that are in testing, and we're doing with some partners as well as just all of our different dev test teams, TME teams. So it's not a monitor module. This one looks exactly like the monitor module, but it's an AC module. Also, just an example of some of the clients. That's a discussion that's always ongoing. I've got a Netgear one that's available on the market. I've also got an early beta of the Linksys, I guess now Belkin, a 1x1 USB, which is a pretty cute little USB, a real nice form factor. So the whole discussion there is that we can have it some other time, but it's really that we're working real close when it comes to not just the infrastructure, but the client-side enablement and where things are at. How do we make sure we're doing interoperability testing? When can we get as many chips as we can possibly get our hands on for testing? All of those types of discussions. So we just wanted to take 30 minutes and make it more free-form, give you an update on where things are at. I want to, give Brian a chance to talk to you guys and have him ask questions with Brian, because he's working very closely with WFA, the IEEE, when it comes to our CTO team. So as far as just a quick update on things, let's get this guy around. So we know that, from just looking at the basics, overall with AC, things are moving towards, and Brian can talk about where the draft and how that's going along on the timeline. Wave 1, wave 2, so step 1, step 2, the module is focused on that initial wave 1, 1.3 gig potential at the PHY, MAC throughput to be determined, and we're doing extensive testing on that guy, so we've got some good hopes on where that's looking right now in our early over-the-air testing. The module you see right there, so it's a plug-in module. It's going to be an add-on, field upgradable add-on to the 3600, and we're looking at a spring availability as far as FCS beta, probably in not too distant future, and that's something we're actively working towards right now in the next few weeks. So we're looking at wave 1, and then wave 2, which is a bigger part of the discussion, where we're also very actively working with the chipset guys on what are they going to put in their chips, and we can talk about that as well. The functionality is not locked down for wave 2. The genesis of it is that it'll take the potential of 1.3 gig at the PHY up to potentially either 1.7 or 3.5 gig on a per radio basis, depending on what the chipset guys put into their architectures. And the big one there is really whether they go to 160 megahertz wide channels. That seems to be a big source of discussion and debate as far as how much do the chipset guys want to churn on their chips. Will they have multiple generations of chips when it comes to their product set? So all these types of discussions we're having with our potential partners. Timeline-wise, I can talk about the product stuff, but Brian, why don't you touch on maybe the standard stuff?
I guess, the IEEE timeline is actually working really quickly. If you remember 11N, sort of the 7-year, marathon, 11AC is much more streamlined. The target is we're going to have it finished by the end of the year, and I think that's really quite achievable. We're at draft 5 right now. Draft 3 was already very mature, and Wi-Fi Alliance that's going to be the basis for the Wi-Fi Alliance certification. Draft 5 we're expecting to be unchanged this go round in order to go to sponsor ballot, and so once you're on sponsor ballot, we can rev it really quickly and be done and dusted by the end of the year. Wi-Fi Alliance certification launch is imminent, sort of March, April kind of time frame, and that's done and dusted. 3 spatial streams, 80 megahertz, 256 QAM. Immediately that rolls, and we've sort of just tidied up some Wi-Fi Direct stuff and TDLS stuff. Then we're going to get earnest discussions about Wave 2. And so, the high-level things are, 80 plus 80, 160 megahertz, 4 spatial streams, multi-user MIMO. And that's going to be, is there enough momentum around each of those features? And I think there's a lot of excitement around multi-user MIMO.
Absolutely, yeah.
160 megahertz creates this really high top-line speed. 80 plus 80 is a bit more complicated. So, we're really going to have some really interesting discussions in the next coming months.
Yeah, I think certainly from our perspective, and I think for a lot of people, multi-user is the big ticket item. That's certainly number one. The 160 is definitely interesting, but maybe for some specific applications and use deployment scenarios, we wouldn't necessarily anticipate a lot of product set to roll out 160 on the client side, but really depends on what that client looks like, I guess, and how special purpose built it is on that part. So that's certainly interesting, and the fourth spatial stream is also part of that discussion as well, right? And it's always, hey, more spatial streams we can play around with when it comes to integrating with clients, the better, and make use of that. So that's good. So the one point I want to touch on here as well, we're not making any product announcements on behalf of any handset vendors on the bottom, but we do anticipate, when hoping that a few of the handset vendors this calendar year will rev their products and come out with what I would expect to be a one-by-one, certainly no more than that in the handset market space. But like I said earlier, we're actively pursuing all avenues, direct with vendors as well as through their chipset partners, and both in most cases, to stay on top of those discussions and urge people. Sure.
But do you think that if the FCC actually opens up the spectrum that they're talking about, the 195 megahertz, that's going to require any chip updates, or is it just a firmware flash to update the chips for them?
Yeah, that's a great question. I don't know off the top of my head all the chipset vendors where they would sit with that, but I would expect some of them, it'll be a mixed bag. And in fact, it might be not, but I'd say it's safe to assume that some may have to look at things. But I know for the most part, the people we're working with have it built in, so the expansion becomes more of a firmware and a software change on the infrastructure side. But yeah, good question on that part.
It seems like the middle bands may be easier as well than the 5.9 gig proposal, which is obviously past, where there's operation at the moment.
Right, and then we are tracking as well, and that's a topic that we were just discussing that we could certainly touch on is, China's opening up things, and from our perspective, obviously, we're looking at the global picture. They've opened up another set of channels, spectrum into 5 gigahertz. We know that Japan is currently at 40. They're looking at expanding up, and then certainly the U.S., a variety of different things opening up that we're very keen on being able to tap in. And I'm not so sure that. I think the other part of that discussion is it how pertinent is all the new stuff within, let's say, the FCC countries when it comes to 160 versus 80. Maybe making the argument that even with 80, there's still some room to play around with. Certainly, assuming you've got DFS access to those channels and the ability to back and off, and that will change things. But yeah, that's certainly an active thing. I don't know, Brian. Maybe you want to touch on some of that as well.
I just want to sort of thank NTIA for their work. I think they're making great progress. We're really pleased with all the efforts.
Right. Because we've been doing some work with the different vendors, I think, as well, right, to open up that spectrum.
Yeah, I'd agree. I mean, it's really good to see the work that's being done to open up additional spectrum for Wi-Fi, and the recognition that Wi-Fi is actually important to the wireless industry, and instead of just selling spectrum to everybody.
Yeah, no, for sure, and especially in channel planning type discussions. So just from a product, we don't need to spend a lot of time. You see it. It's Wave 1, 3x33 is the module, is the aim of the module. So 20, 40, 80 megahertz wide channel capability on that guy. It'll have the beamforming, even though it's an option. It'll be there in the product, the ECBF type functionality. We can certainly get into more on the product itself, but that's not really the intent here on that part, to talk about so much about that. This just goes back to that discussion about Wave 1, Wave 2, and some of the differences in Wave. Wave 1's a known entity. Wave 2 is still up in the air, as we mentioned. It's either going to be, well, assuming a fourth spatial stream, it'll really be 1.7 or 3.5 at the PHY level, and then again back to the whole MAC efficiency. What can you do in your product to make sure that it's making the most use? But certainly multi-user MIMO, and then the number of concurrent clients you can connect to is really the big one that we're focused a lot on when it comes to Wave 2. Now, having said that, we're not in a position of having anything committed, but we're actively looking at Wave 2. For sure, we'll have Wave 2 product, and then it's going to be interesting to see how we can implement and expand upon things to make things as interesting in the product set as possible. Go ahead.
I know it's a big topic, but how do you answer people who say, why don't I just skip Wave 1 and wait for Wave 2? Why do I want to dump a boatload of money into this when it first comes out? and then turn around and dump another boatload in 2 or 3 years?
Yeah, it's a great question. So realistically, I think it's going to come down to a couple things. We've got a set of customers who are in a position that they're in planning to rev their network. They've had very early end product and occasionally no end product in their architecture. They're in a position, they don't want to wait, let's say, another 2 years, because we do anticipate the Wave 2 products until the very end of calendar 14, beginning of 15, when it comes to clients as well as enterprise class grade and BYOD integrated type products. So it comes really down to timing for the most part, I think. Even aside from the 1.7, 3.5 and the multi-user part, we do have a few customers who are adamant about waiting for a few, multi-user because of the single user aspect. But we do have, I'd say the majority of the customers are in a refresh mode. They're extremely interested. They've got network growth issues that they're dealing with, whether they're in the higher ed market space or the healthcare or manufacturing. Some of those guys are, I'd say the higher ed is definitely more in the picture of where they've got network bandwidth issues where it's just doubling on a 6-month basis. And they know that there's going to be a series of products coming out with AC into their campuses the end of this year. And they've got some concerns on the bandwidth. So it's really going to cut across the gamut in that case.
So then let me just ask you a quick follow-up. I mean, and again, it's just not a fair question for anybody. But
having said
this is getting so complicated compared to where wireless came from. It used to be you could talk about going from 11B. Going from 11 to 54, when you go to A and G. That's easy to talk about. This is like, you're seeing it right there. You need a matrix just to understand what the hell's going on.
Yeah, but
so, I mean, are you finding, we don't, you don't, I don't,
okay.
I know that, but I'm saying customers and people who aren't so tech savvy, do you, again, not a fair question, but are people's customer ignorance going to work to the vendor's advantage?
I see the unfair part now. Yeah, okay, I'm getting it now.
It's AC, and now it's AC better, and even better. And
I think honestly, it depends on how you approach the customer. And from our perspective, we're really trying to provide the value. The tough part, I think, for every product manager and the TME, I'd even say, is that articulating the value proposition. The tech stuff is easy to do. It's a value prop, and I think that when it comes to it, what we're really focused on is providing as much data as possible to our customers. Our customers are definitely, they're definitely AC aware to some extent, and it's going to vary, just like any technology. Some of them are right on top of it, and this is where we get into the whole discussion about, well, single user, I'm just going to wait for multi-user. I'm good enough with where I am. But so we're really trying to arm our customers, engage them. We've been actively engaging them for over a year, and it's really going to be, at the end of the day, what's your business driver? Here's what we think it can do. Here's what we know it can do. Where are you in the buy cycle? Where's your network? What kind of clients do you see integrating? Are you waiting for a specific type of client? And then we try to leave it up to them at that part. So, but no, agreed. It's definitely interesting, especially when probably the biggest discussion around this whole thing when it comes to productization and deployment is going to be power draw. So with the module, it's above 15.4. So you get into enhanced PoE with the older Cisco switches or PoE plus. The other part of that then becomes the uplink speed. We're very comfortable that single full duplex gigi uplink from the APs for Wave 1 is more than sufficient. And for a number of different reasons. One of them is just the mix that we expect with clients. We do expect the client mix to stay fairly similar to what we're seeing within. Maybe more two spatials, depending on how the Intel inroads with their Ultrabooks and what have you that are going to come out strong. But I'd expect there to be 1s, 2s, healthy 2s, and then 3 spatial to be like an N, the lower percentage of the user base today. And given that and just how the math plays out, we really feel comfortable that a gigi is more than sufficient. Now, Wave 2 changes that whole paradigm, and there's a ton of discussions on, as I mentioned here, I added this column. It's got nothing to do with the technology, but the row at the bottom, simply for that discussion that says, we do see the potential of offering multiple uplink connection speeds in the future, and that's all to be played out. At this point, nothing firm in product, and we'll design the Wave 2 products are likely to be designed from the ground up, and we'll tackle it at that point.
Some good business. It's just Cisco idea than upgrading people to 10 gigabit.
Well, it's going to be needed, I think. Certainly as we envision single, dual 5 gigahertz radios, doing 1.7, 3.5. So you could just right away, we're going to need to have some really interesting and intelligent solutions for customers to offer, and that's something that we're actively pursuing at this point as well.
With 3 streams, the third stream, like even on 8 to 11N products, the third stream you generally need to be relatively close to the AP or closer than say
Yes.
2 streams.
Yeah.
With 4 streams, presumably that may be the case, maybe to a greater degree even, and then on top of that, if that is the case, you've got 256 Quam, and I believe it's the same. So
right, it's all rated range type of discussion, right? And
so how is that going to, do you expect the density, I mean, obviously we've been saying for quite a few years, capacity over coverage, 10-year-old wireless LANs were
you want me to
much
go to
lower
that?
density, so...
I'm going to say that, obviously going to wider bandwidth actually helps you a lot. If I want a certain speed, 64 at 40 megahertz, I need 64 QAM. As soon as I go to 80 megahertz, I can drop down to 16 QAM. And anything above that, 64 QAM, 256 QAM, that's all a bonus. But I totally agree. More spatial streams. It is a challenge. So there's a bunch of techniques: beamforming, LDPC encoding, all these. Just having 4 high performance antennas with signal processing behind them. All of these are sort of, they're not sexy features, but we make sure they're in the product to make this, as range effective as possible.
They're absolutely sexy features. Come on, man. 4x4 dual band, but
But I think, like you said, and because AC specifies a minimum of 80 megahertz, although you don't have to use 80, right? You can still configure your network for less. If you are using 80, then you're still getting that extra bandwidth without needing 256 QAM necessarily to get the extra data rate. And you could have 2 streams at 80 megahertz channel and still get a high data rate.
So actually, one of the next one will be interesting too. We talk a little bit about the protocol part, because I think that gets to the whole channel usage and the implications on channel planning could be derived and discussed in that case. You could definitely run a 40 with AC. In fact, you could run a 20, but we're not sure what the real benefit at that point would be. But the whole dynamic nature of the protocol as well is something that needs to be factored into the equation. It's going to adjust itself accordingly. But you're right, the rated range, the same rated range discussion with N as it is with AC. We're not sure that the area changes at all. I wouldn't expect it to, the actual radius of the coverage. But we are definitely interested to see, when it comes to that close-in connection, what's the first waterfall? And does the distance move at all? That's something that we do anticipate potentially. But again, it's all going to be depending on what's in the environment and what have you. But the initial returns are encouraging as far as what we would expect from a performance boost and perspective on the product.
The channel conversation though isn't just about, hey, how many chunks can I get in my spectrum? It's also about backwards compatibility too, right? How many 8 to 11N clients do we have today that can't use all of 5 gigahertz? And you're planning on putting in a new infrastructure that does support those channels, you're going to leave a bunch of those 5 gigahertz 8 to 11N clients out.
Well, it's the same now, isn't it, with 8 to 11A clients don't support.
That's
Oh,
right.
sorry. Why would you leave it out in the cold? I guess is.
But if you've got infrastructure running in Uni 2E for 8 to 11 AC, expecting to provide 5 gigahertz 8 to 11N compatibility for those same clients in the area, and those 8 to 11N clients don't support those channels, you're going to starve them out or force them over to 2.4 gigahertz.
So I wouldn't say that that's unique to 11AC. I think that's really a channel planning problem.
Well, exactly.
And absolutely, we have that challenge today, and we found ways to solve it. Actually, I think there's some really interesting things we can do to make it better with 11, in an 11AC time frame. But what I think on the flip side, we are seeing an enormous number of new devices that are supporting more and more channels.
Yeah.
And actually, we have an initiative underway at Wi-Fi Alliance to try to encourage everyone to support all the 5 gigahertz channels.
Is there any, on Cisco controllers, I can disable all the B data rates, and that's obviously been recommended for quite a few years now, if you can. But you haven't been able to do that for A, and I'm seeing confusion as to whether that's a standards issue or, so I wanted to disable A in new N designs I've done. So majority of A clients are ABG, so they'll just connect at G. Because pretty much what Sam was saying, you've still got A clients that don't support Uni 2E. If you want to start using those channels, will there be a way to disable, to drop support for A in the infrastructure?
There is a way to force the minimum entry requirement into an 11N or 11AC AP, you can mandate that, you know, 11. There is a standardized mechanism to say, you know, if you don't support 11N or you don't support 11AC, you can't even associate to me. I would say that 5 gigahertz is a better position than 2.4 gig.
Yeah.
You know, 2.4 gig, you had this, 11B has this really long preamble, and if you send a CDS to self, then you're adding extra overhead. 5 gigahertz has really been designed beautifully in the sense that we're really using the same preamble as 11A. So even when I transmit an 11AC frame, an 11A device doesn't need an CTS to self ahead of that. And you know, the preamble, an 11A preamble is actually still the most efficient preamble that we have.
So that's from a performance perspective, but I guess I'm thinking more of coverage holes where you've then got that AP on channel, what's a Uni 2E, channel 112 or whatever those middle channels are. And then you've got a coverage hole basically, or if you're using channel 165 and 7925Gs, you're going to have coverage holes for the same sort of reason. So that's more where I'm coming from than a performance perspective. Just so because there's more those clients, some of those, there's still ABG clients around, of course.
Yeah.
Sure.
So
We're talking about making sure that the clients that are connecting are supporting specific standards like 802.11h, so you've got the DFS support there, and you know that all the clients you're letting on your network are going to support these mechanisms.
It is client by client. I mean, in general, every network is different, but in general, we'd like to help every client to get on the network.
You kind of had away with that with 802.11n, right? With the greenfield mode that you put in, that nobody actually even really implemented.
the clients have to support that, and apparently a pretty small percentage do.
But that would be like one way of that type of mechanism being able to make sure that I want to set up my network so that it's only going to support this.
Right. Yeah, we've seen that request float in, and but nothing that's been really serious enough to warrant given a mixture, typically of the clients. But why don't we talk about this part as well, and how it relates to the backward compatibility, because I just don't see it being a case where we're going to be we're certainly not walking away from clients. And then the channel planning is absolutely a big part of the discussion, given the breadth of where you can go. But the protocol itself seems.
For sure. So yeah, one thing, once you get a wider bandwidth, 80 megahertz, even 160 megahertz, suddenly you're going to be overlapping with a lot more APs, and they could be legacy APs, maybe from your existing deployment or maybe your neighbor's deployment, above or below, wherever. So it's quite likely there could be, even an 11A, certainly 11N device on a set of channels, but the adjacent channel is relatively free. So how do you use 80 megahertz in the situation where this other channel is busy? So one thing that, we added a number of improvements to 11AC, better CCA, so it's more likely that a guy who wants to transmit detects this in the first place. But, there's certain circumstances where, CCA won't work. The initiator can see the responder, but this interference is sufficiently far away from the initiator that it's going to affect the responder, but it's just not visible at the initiator. So what we did is added RTS with bandwidth indication. So the initiator, who's relatively far from the interferer, says, I want to transmit over 80 megahertz. And then the responder says, well, actually, I hear some real interference nearby. I don't want to transmit over the top of them because that's going to create a collision and just degrade performance. So, and I won't be able to receive the packet either. So let me send a CTS back saying, well, actually only 40 megahertz is free, and that helps the initiator to send data without colliding with this guy. So this packet goes through, and this guy doesn't collide either. So this is a way that you can more reliably take advantage of wider bandwidth channels.
I can see how that would be more reliable, but adding RTS, CTS, when you look at the actual time, how long it takes for the preamble and the header, and the RTS is baby, but the preamble and header take a lot of time. You just added 2 whole packets worth of preambles and headers in front of a data frame, and you're hoping that because it's 80/40, it's better than the 20, but you had to send all those other little packets. I'm just concerned about the amount of time it's going to congest the network. Yes, that one device is going to get a more reliable throughput, but how much time did it take to do that?
Yeah, I mean, certainly, with the aggregation here, it's optional to initiate this. So, it's really part of a multi-dimensional optimization. How do we use the channel most efficiently? So if you've got a longer packet to send, if over time you're pretty aware of the busyness of this channels and whether that's called for. So if this is very highly busy, you wouldn't even transmit that. You'd recognize it and select 40 megahertz.
So it's not merely an option, it's a dynamic option.
Yeah,
Right.
it's 11AC is very, very dynamic. On a per packet basis, I can choose to try and transmit 20 or 40 or 80 or 160.
Or with or without the RTS?
Yes, yeah,
Okay.
yeah.
So that's where it was saying earlier, but you look at those aspects, and now you've got something that can actually adapt to the environment. And I think certainly there's going to be a lot of interesting data to be gleaned in the first pass of this first year as it rolls out, and the first set of testing, just to see the reaction. And
I'm just afraid of
what have you.
something that Lee brought up in the little pre-discussion. This is relying on clients being really good. And we haven't, I mean, they have to play the game.
Yes, yeah. Absolutely. This is a mandatory requirement to support the CTS response.
Are there actually chipsets supporting this that you've been able to do testing on to see what the performance impact is of it?
At the moment, we're working through the Wi-Fi Alliance to get this certified, and that's an absolutely mandatory part of it, and the system testing is ongoing.
Yeah, so I don't know where they would be in a rev. I'd have to check if it's a rev in their product, if it wasn't there already. But to your point, the other part of that would be, the first part maybe, it's a mandatory component of WFA period for the interoperability test. So that's obviously critical, not critical, but huge, right?
Yeah.
Helps to pull things along. And then we could certainly check on the chip side, because there are definitely drops of stuff that came out with chips from the chip side guys. Like ECBF wasn't there day one for the majority of the chips. It was something that was added via software afterwards. The hardware was capable.
What is the actual name? This is another protection mechanism, essentially?
Yeah,
What is the name
we're calling it, you won't find it in the spec, but an early name which is kind of stuck to it is RTS with bandwidth signaling.
All right.
Or RTS CTS with bandwidth signaling.
And how, I can see that having the CTSs in there can be part of the spec. But the dynamicness of when it turns on and off and is used, is that also part of the spec?
That is subject to individual optimization.
Yeah.
Back to my client question.
Sure, but that's inherent within networking, right? I mean, I see
know,
where you're going. No, and
more and more complexity, something that the client side hasn't really figured out how to do that good right now. And
well, I guess it's. I mean, certainly that's. I'm not saying. I wouldn't say it's wrong. I'd say that's again. I'd say it's a standard part of networking, and I'd say there's one element of it is going to be time of the chipset to market versus price point and maturity of the target market of the chipset. For instance, the first A0 type chip drops in the products that are out today versus a more mature implementation of the same chip, which definitely makes a difference. But yeah, so those will be things, and this is back to my other comment where certainly extensive testing but also as we go through is going to be extremely interesting, as well as just staying on top of the WFA and every other interoperability form we can be involved in.
You mentioned when you first started that the life cycle has accelerated compared to the N's life cycle.
Yeah.
One of the things we saw with N was the first rev of solo quality ones. We kind of just tossed them out. They didn't play well. Are you seeing the first rev of that AC a little more robust and more mature than they were on the last cycle?
I'd say that they're definitely capable. I mean, you can connect. I mean, they've got all the things you'd expect from a consumer, or let's say that market dynamic, meaning distance. It doesn't take long for things to fall off the map when it comes to distance. The ability of being able to sustain the full 80 megahertz as opposed to going down to 40. Depending on your environment, I've definitely seen that firsthand myself. But no, I'd say overall, I mean, they're good. They're using the very first chip drop from the vendors.
I would say that 11N was a huge jump over 11ABG. You had aggregation, you had MIMO, and so forth. 11AC is more evolutionary. We understand MIMO, we understand aggregation.
Right.
So essentially, we've given you a faster car, but the controls are pretty similar.
Yeah. That's actually good news.
Yeah.
Okay.
Great. Okay. I think the other thing we had up here was this build on multi-user MIMO. The whole. Did you want to just talk? I mean, it's pretty well known, but.
So single user MIMO, this is 11N. You have an AP, it's transmitting to each client in turn. So first I transmit to one client, then the other, boom, 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 boom. With multi-user MIMO, I'm transmitting multiple spatial streams separated to individual clients. So I'm transmitting to 2 clients at the same time, another 2 clients at the same time. And so when you have this, highly capable AP, 4 antennas, multiple RF chains, transmit beamforming, transmitting to, say, a smartphone with 1 antenna, it's not taking full advantage of that capability. Obviously, you've got beamforming, so you have a really reliable link, but why not transmit to 2 clients at the same time? And that's where multi-user MIMO comes in.
So it's probably very well understood, but certainly again back to the Wave 2. That's certainly in our mind, the #1 feature, and then all the other stuff certainly will take as well for sure.
Does this rely specifically on the client being able to feed data back to the AP with the spectrum analysis parts of the standard?
There is a sounding protocol defined in 11AC, and one good thing that we did in 11AC that we didn't get right in 11N. 11N had like half a dozen incompatible modes, and the industry never rallied around any of them.
Yeah.
So client link, implicit sounding, these are the technologies that actually succeeded. With 11AC, we've just defined a single sounding mode. Mm-hmm. So, and we're seeing a high degree of clients supporting that. So it's much more likely that clients will send sounding frames, but there's still no fundamental requirement that you need sounding from clients. Every time, particularly one spatial stream client, anytime that guy transmits, the recipient is essentially getting sounding.
Right.
So I think vendors like Cisco with our client link heritage are actually really well placed.
Yeah, and then to that point, so far we haven't, even though it's optional, the beamforming, everybody we've talked to, it's baked into the chips on the client side. So that's definitely a big change from what we saw before.
So, quick question for you on the multi-user MIMO. It's not just Cisco, I've heard other salespeople talk about, and wireless finally gets to be like switching. What do you say to that?
Yeah, I mean, honestly, it's back to the discussion we were having before.
But to what extent, though? I'm sorry.
Sure, no, yeah. So I think the first part was that that's an easy way for people to get it, right off the bat. So that's where that terminology, certainly, I've used it myself. And I think that where I was mentioning before, at the end of the day, this is where products get a chance to differentiate themselves as to the scale and the scope of what they can implement and how they can envision the technology being used. And certainly we see that. And that'll play out in the number of concurrent users, the antenna chaining capability that's going to be there to really take advantage of the number of clients. At the end of the day, this guy is really going to be dependent upon not just the protocol, but the number of spatial streams that we can get into that chip, and then the math that lets you add up to that number based on what your chaining and your antennas infrastructure is like. So, we pride ourselves certainly from a product and technology perspective of being right up there and forcing that, and we don't see that changing with Wave 2. In fact, we'll just keep pushing that envelope as far as we can go. But yeah, so you can get let's say 2's nice, but ideally it'd be great, three single spatial stream, or one and 1 2, or 1 3 spatial stream client, or combinations thereof. So you get the opportunity to play with it, get it going concurrently. And then, so I guess the other part of that question is it's definitely more switch-like in that context. But, and then the overall capacity and capability of the box itself to be able to sustain, obviously, not just the uplink, but the internal components of the box, right, to keep that, maximize that MAC layer efficiency. And so they're all coming together. So obviously the end goal being maximizing the throughput capability.
Sure, and I guess my only problem with that broad statement is it's more like a mini switch than a switch.
Yeah, it's not a take on access layer. I will say to my brethren, it's a shared access layer now. Get over it, type of thing. To the switch guys, and joking with the switch guys, but the reality is it's a very symbiotic, interesting relationship. Obviously both sides bring a lot to the table. The mobility aspect of wireless is what it is, And here what we're just talking about is instead of one at a time, hub-like shared medium, you're now talking about an environment that can be sliced and diced concurrently. So, but yeah, it's not a switch per se on that part. So that's kind of what we had. Were there any other questions on quickly, we've got a couple more minutes before Brian's got a boogie.
Yeah.
Can we take apart the module and take pictures of it?
No.
Just one other question with multi-user MIMO. It seems from the diagram that you've got the clients quite far apart. Is it
Yeah.
going to be more like beamforming where it's talking specific to a specific client and then you can talk to one that's nearby?
Yeah,
Or
this
does
is
it have
yeah,
to-
this is
yeah.
diagrammatic efficiency.
Yeah.
You know, I think once you get within half a wavelength, you have real problems. Now, half a wavelength's a couple inches, so
Right.
you know, once any reasonable human scale spacing, multi-user will do fine.
Right. Personal space will kick in at that point.
Yeah.
But yeah, no, this is just a representation.
A single gig port on the back, I imagine.
Yeah, and that's what
Power requirements.
power requirements for that module are 18 watts. So enhanced PoE or PoE plus. So enhanced PoE on the older switches on that part
Can
of
you use
or
AF
PoE
to
plus.
just take down some of the rates?
You could, I mean, you could disable the 2.4 radio, and that's something we're looking at and reclaiming the power and bring it down. But that's kind of a work in progress at this point. But 18 months.
You know, one of the things that I know Scott, he's not here, he walked out, and one of the things that I've had problems with is, you know, when we turn off that radio, is there any way we can, or are there plans to use that radio in monitor mode?
So
Yeah.
that's definitely something that is a general. So the other module that we started shipping, it's a monitor module, the WSSI. We actually implemented that architecture to allow that radio to be in monitor mode while the other radios are in local mode. So the architecture's there, it's just not generalized at this point. So yeah, there definitely is a plan to eventually roll that, make it more part of the standard part of the infrastructure on that part. So going forward, we are also looking at different, you know, let's say power policy, if you will, like a lot of the networking devices where a little more flexibility around some of the down revving potential. So that's something in the future, but right now we're just trying to see what we can do near term.
And what about long term? Do you see the access points having 2 gig ports?
Well, like I was
Gig
saying
ports gonna
earlier,
be-
we haven't really locked down on what that's going to look like, but definitely we're going to address for wave 2,
Yeah.
we'll have a need to look beyond the single gigi, and how that looks physically is all kind of in the works. So we got some interesting stuff that we're kicking around, but yeah, definitely.